Hello, I'm Anthony Ingram Westover, and I am presenting my solution for the 8 puzzle problem in Python. To start out with, we'll just run the program. The initial command is just 8 puzzle without any parameters, and it asks you to enter in the 9 digits. For this, I'll just go with a nice simple in order. So we're going to separate each one from 0 through 8, separated by commas. And once you do, it's going to ask you how you would like to solve the puzzle. So I'm going to use the third version, my custom heuristic for the A-star algorithm. And you see it works rather quickly, prints out and lets me know from the start what I initially entered. This is a way of saying 1, 2, 3 in the first row, 4, 5, 6 in the second, and 7, 8, 0 in the last row. Shows the movement, how much it cost. In this case we moved 6 to the right, and the total cost. See, my heuristic in this one took a total of 10 checks before it reached the goal state of 1, 2, 3, 8, 0, 4, 7, 6, 5. Then to go through some of the code you see here, I have a few global variables here at the start. These provide a few different things. The states, which is what I'm currently looking at. Tried is a list of what I've already expanded, so I don't have to worry about infinite loops. Weights, costs, and directions are just areas that show the equivalent total weight, the individual cost of each move, and the direction as in right down. Parents is an index showing from each state what was the previous state that I got there, and all states is just a list that contains every state I've ever expanded. It's for use with the parents list. Since I pop off of states to clean it up a little bit, that keeps all of them. Nodes checked tells me the total number of nodes that I expanded before I reach the solution. The solution is my goal, which you see is 1, 2, 3, 8, 0, 4, 7, 6, 5. The total cost is similar to nodes checked, but it runs with the total weight. And the start puzzle is just a little catch-all I did to store what the user initially entered. So just to quickly go through this is the prints that you saw on the other screen, asking them what to start and how to start the puzzle. It converts it from the string that they entered into a two-dimensional grid. And then once that's done, we begin the solution. Depending on what number they entered, we can do breadth first search, depth first search, iterative deepening, best first, uniform, or any of the A stars. So I'm going to go through just each one of those real quick. For the breadth first search, it starts out pretty simply. We find the empty spot in the grid, and then we figure out all the different possibilities of where the empty spot can move. Can it be moved to the right? Can it be moved to the left? Can it be moved below or above? And then for each one, if we haven't already tried it, then we add it into the list and we add the weight, the direction, who its parent was, all the necessary information. And you do that for each one of the 4 possible directions. For depth first search, it's somewhat similar. However, in this case, when we add a state, instead of continuing on, as you notice, this was all ifs. In depth first search, once you add a state, if you correctly added a state because it didn't exist before, then we recursively start going down that depth. And other than that, it's all the same as breadth first search. Iterative deepening actually uses breadth first search. However, it specifies which depth level, and at each time, if the solution has not been found, then we start over with a recursive call to the iterative deepening with a higher depth. If the solution is found, then we let you know that. For best first, again, we are utilizing breadth first search. In this case, we don't care about specific weights. However, we check the best score using the total number of correct tiles. Uniform cost is similar, however, with a weight. And for the 3 different A stars, it's all one algorithm that just has 3 different score solutions. My custom heuristic just multiplies the 2 other ones, the Manhattan distance with the total number of correct. And then my solution to print out the full list. I just iterate through in reverse order from solution back to start.